Hello, welcome to this video. This is a series of videos about international trade theory. In this video, we'll introduce the theoretical framework of Eaton and Kortum 2002. And in the next video, we'll introduce several empirical applications of EK model. Eaton and Kortum 2002 is an extension of DFS model to an arbitrary number of countries. They provide a framework that combines technological progress with geography to shape comparative advantages. And the EK model generalized Ricardo by employing a probabilistic approach for the concept of comparative advantage, and also provide a methodology to take the Ricardian model to the data. That's why this model is popular in the trade literature. The authors not only focus on the goods market equilibrium, but also analyzes the labor market equilibrium. That's what's missing in the DFS model, and enables this model to perform counterfactual analysis, which provide a powerful tool for policy analysis, such as the impact of tariff and technological changes on trade patterns and welfare. And the EK model also quantifies the diffusion of technologies through trade, demonstrating how international exchange enhance global welfare by spreading productivity gains across countries. So let's say the basic settings of the EK model. The EK extends the DFS model to many finite countries with a continuum of goods on the interval 0 to 1. They assume there is only one factor, labor, in the economy, and it's immobile across countries. The cost of a bundle of inputs, say I, are the same across all goods J within a country. They first take it as extraneous, then they break the input cost into the labor cost and intermediate input cost and model how they are determined. They assume constant return of skills. It means that the cost of producing one unit of goods J in country I is Ci over Zi. So the lower the input cost and the higher the efficiency, the lower the production cost. In Eaton and Kortum 2002, they introduced iceberg trade cost DNI between country pairs N and I. So that's important. That's how they combine the geographical factor with technological progress in shaping comparative advantage. So based on all of these assumptions, one unit good J produced in country I to country N cost PNI is a function of input cost Ci, productivity Zi, and iceberg trade cost DNI. They assume all markets of goods J are perfectly competitive. It means that prices actually paid from consumers in country I for any goods J is the lowest price from all possible providers. And choices may differ across countries because the existence of DNI. That's transportation cost between country pairs. So it means that in the EK model, more than one country can produce the same good, while individual countries supplying different parts of the world. On the demand side, they assume the CES preference. Consumers will solve the maximization problem. That's the standard CES preferences and standard consumer problem. If you solve this maximization problem, you will get the CES form aggregated price index. So the demand side is totally standard. Then for the technology, country I's efficiency in producing goods J, Zi, is a realization of a random variable Zi from its country-specific product probability distribution. So here you could say that the capital Zi doesn't have a subscript J. That's because the distribution of efficiency is assumed to be the same for all goods within a country. And the subscript J represents each specific draw from this common distribution. So the likelihood that country I supplies a particular good to a country N is the probability that I's price turns out to be the lowest, because each country will actually buy from the lowest price provider. For each good J, the distribution of country I's productivity is following a Fréchet distribution in this form. We could say Ti here is a location parameter, is country specific, and the higher Ti represents higher productivity draws is more likely for any goods J. It represents absolute advantage of an economy. And theta is greater than 1 determines the dispersion of productivity, where a higher value means less dispersion across countries. So it represents comparative advantage of an economy. So why they assume the productivity is following Fréchet distribution? You could check my last video. I introduced more about the three extreme value distribution in that video. And here, in deriving the EK model, they assume the productivity is following Fréchet distribution. It is also because of its useful properties. The first property is that if one variable is following the Fréchet distribution, then this variable multiplied by a constant is still following the Fréchet distribution. Second one, if one variable is following the Fréchet distribution, then the minimum value of a list of this kind of variables is still following the Fréchet distribution. It's especially useful to characterize the most productive producers under perfect competition in the perfect competitive market, because we assume that each country will actually buy from the lowest price provider. The last important property is that if J is following the Fréchet distribution, Ki is greater than 0 and they are independently and identically distributed, then the probability that Ki over Ji is smaller than the minimum value across all Kj over Zj can be written in this form, in this very simple form. So this is an essential property for EK model to solve for the analytical solution. That's why they assume the productivity is Fréchet. It's not only because it's closer to the reality and the real data, and it's also because of several useful properties of Fréchet distribution. It makes them easily to find the analytical solutions of the model. Okay, now knowing the three properties of Fréchet distribution, we can see the price determination in EK model. What we have already seen is that the unit cost PNI is a function of CI, ZI, and DNI. And according to the first property of Fréchet distribution, we will know the probability that country N buy any goods J from country I as actually, we could see here, if you replace the function of PNI into the distribution, the probability distribution function, you can express the variable Z in this form and rewrite it in this form. You could say that according to the first property, if Z follows the Fréchet distribution, then Z multiplied by a constant also follows the Fréchet distribution. So we can say this term is actually K multiplied by Z. It should also follows the Fréchet distribution, and here basically we replace Z in the Fréchet distribution. We have seen in this slide, we replace Z here with this term. We will get this probability distribution that country N buy any goods J from country I. Then let's say the price for what N actually buys. It should be the minimum price from all possible providers I to N. And according to the second property of Fréchet distribution, we know that a minimum of a list of variables that follows the Fréchet distribution still follows Fréchet distribution. So Pn also follows Fréchet distribution. And if you use the second property, you can finally get the expression of J and P in this form. Here, the price parameter phi n is a weighted sum of each country's technology level, where the weight depends on trade and production. So here is a weight. It depends on the trade and the production cost. This weight reflects how accessible each country's technology is to country N, considering production cost and trade cost. So lower costs lead to higher influence on phi N. And here, on this slide for the price determination, you should note that there's a difference between Pn and Pni. It's important for us to understand the model. The Pni is the price of goods J if country N buy from country I, while Pn is the actual price country N paid for goods J. It's from the country providing the lowest prices. Let's say the three properties of the price distributions. The first one, the probability that country I provides the goods at the lowest price in country N, pi Ni, according to the third property. Here, the K in the third property is Ci multiplied by Di. Here we could say it's Ki. So actually, this term is Ki. We saw in the third property of Fréchet distribution, smaller than the uh, price from of all other countries. According to the third property, we can write this property in this form. Since there are a continuum of goods, this probability is also the fraction of goods that country N buys from country I. The probability B is that the price of the goods that country N actually buys from any country I also has the distribution J and P according to the second property of Fréchet distribution. Finally, the property C is that combining CES price index and the supply side price index, the Eaton Kortum express the price index in terms of technology, factors, and trade costs. Here I give you a clue on how to solve this problem. You need to know that the aggregate price of each good over all goods. So here the aggregate price of each good here dj over all goods on the interval 0 to 1 is equivalent to the aggregate price that if we aggregate the expectation of price. So here is the price, there is the possibility of getting each price. So this term is the expectation of each price over all possible price levels. Then you make use of the gamma function, you will get the aggregate price index Pn in this form. We can rewrite it as a multiplication of gamma multiplied by phi n with the power of minus 1 over theta. Okay, now let's see the expression of trade flows. The fraction of country n's expenditure on goods from country I is xni over xn. We can write it in this form. The nn is the total number of goods consumed by country n, and nni is the number of goods consumed by country n from country I. Okay, so these two are the number of goods consumed by country n, and PNI and QNI are the price and quantity consumed by country N from country I. The PN and the QN are the prices and quantities totally the total price and The Pn and Qn as aggregate price and total quantity consumed by country N. And the pi Ni, that's the probability that country N actually buys from country N. We can represent it in this form. It's the ratio of NNI over NN, so the number of goods consumed by country N from country I over the total number of goods consumed by country N. And here we want to know whether these two forms are equivalent to each other. From the probability B here, we will know that the price of a good that country N actually buys from any country I also has the distribution JNP. So it means that PNI and PN here has the same distribution. According to the CES preferences, if the price level has the same distribution, then the quantity level will also have the same distribution. So these two terms can be cancelled out. So we know that the fraction of country N's expenditure on goods from country I is actually equals to the probability that country N actually buys from country I. And from the first, the probability A, we will know that the trade share of country I in the total expenditure of country N can be represented in this form. Then if we assume the exporter's total sales are QI, then QI is actually the sum of trade shares of country I in all importer partner countries. Basically, we should sum the trade share of country I across all countries, all importers. If we solve for TIC I with the power of minus theta from the function of Qi and substituting it into the expenditure function and incorporating Pn, basically we will get the expression of xni, that's the bilateral trade flow between country N and country I, in the form of here we could say this function has the standard gravity form. Here, xn is the total expenditure from importer, qi is the total sales of exporters. So these two are actually the country size of can represent the country size of importer and exporters. And in the denominator, changes in input cost and transport cost affects the probability that a country will be the lowest price supplier, which in turn affects the number of types of goods imported rather than the volume of import of each good. So from this bilateral trade flow function, we can also find that the response of trade shares to cost and geographical barriers occurs as the extensive merging instead of the intensive merging in the EK model. Okay, then if we take log of the bilateral trade flow function, we can get a function of the bilateral trade flow in this form, and we can separate these four terms into the exporter fixed effect, importer fixed effect, distance, and country size. The share of country N in country I's total sales equals to N's share of I's effective world market, and the sensitivity of trade to cost and geographic barriers depends on the technological parameter theta rather than the preference parameter sigma, we could say in this function. And the trade shares respond to cost and the geographic barriers as extensive merging rather than the intensive merging that in other models invoking Hamilton or monopolistic competition. Country I's normalized import share in country N, we can represent it in this way, and using this function, and actually we can estimate theta from this function. The higher theta implies more elastic import shares with respect to the average relative price and to geographic barriers
because the larger the theta is, the more concentrated the Fréchet distribution is, and the lower the variability of technical efficiency across goods. So the comparative advantage is weakened as differences in the efficiency between countries producing different goods narrow. Okay, a higher value of theta means relative efficiency are more similar across goods. So the comparative advantage will be lower. Okay, then so far, Eaton and Kortum takes the input cost CI as given. From now on, the endogenous input cost for counterfactual analysis. They assume there are two inputs, the labor and intermediate inputs. The input cost is aggregated in the Cobb-Douglas form. Beta is the constant share of labor cost, while 1 minus beta is a constant share of intermediate input.
Then we can rewrite this equation and get the expression of real wage. Omega I is a nominal wage level, so omega I over pi is real wage level is a function of input cost CI and PI. You should note that PI here is the price of intermediate goods for manufacturing as a whole. So it means that the production of intermediate goods also requires inputs of labor and intermediate goods. That's the same as production of final goods. Then combining with pi ni is the probability that country N actually buys from country I, and the aggregate price index Pn, we can express the real wage level in terms of gamma, technology level, and pi ii is expenditure on domestic goods. Then they show that the price levels are mutually determined given wages, and they rewrite the expenditure share according to the new price index. So basically, under the general equilibrium framework, they rewrite the price index and expenditure share as we have seen before. Then let's say the labor market equilibrium, and they will show how wages are determined in this part. Firstly, solving firms' cost minimization problem, they get the labor market clear condition. It tells us that the labor income should be equal to the labor cost. The labor cost is a multiplication of labor cost share and total expenditure on N's goods. Because they assume that the manufacturing is the only sector in the economy. Then total manufacturing expenditures are the manufacturers as intermediate and as final goods. If labor is mobile, which means that workers can move freely between manufacturing and non-manufacturing sectors, the wage rate is given by productivity in non-manufacturing, and the total income yn is extraneous. So we can write the labor income in this form. And if labor is immobile, it means that the number of manufacturing workers in each country is fixed at Ln. That's the fixed labor supply. And if we assume non-manufacturing income as YNO, then we can rewrite the labor income in this equation. Okay, now so far we have the four equations that comprise the four general equilibrium. However, we can't get any analytic solution because of the mutual interaction among prices in different countries. That's why Eaton and Kortum use two special cases for solving simple closed form solutions. The first case is zero gravity. So the law of one price will hold in this economy, and thus the labor market equilibrium reduced to this form. You could see on screen. And from the labor market equilibrium, we can derive a function of welfare, and under Auto-K, we will write the Ti equals to Tk and Li equals to Lk. So welfare under Auto-K will reduce to this form on the screen. For more details about the derivation, you could check my website. I will upload some notes on the derivation of the model. Okay, so in this video, I introduced the theoretical framework of Eaton and Kortum 2002. In the next video, I'll introduce some empirical applications of Eaton and Kortum model, not only those applications in their paper, but also some more recent research. Thank you for watching this video.